Look up at the night sky. Those tiny points of light, most of them are entire galaxies, each containing hundreds of billions of stars. The observable universe contains roughly 2 trillion galaxies. 2 trillion, and each galaxy contains hundreds of billions of stars. Many of those stars have planets orbiting them. The latest estimates suggest there are more planets in the universe than there are grains of sand on every beach on Earth. And so here's the question that keeps scientists awake at night. With so many worlds out there, where is everybody? Now, this isn't just a casual thought experiment. It's called the Fermi paradox, named after physicist Enrico Fermi, who asked a version of this question back in 1950. Fermi was having lunch with his colleagues when the topic of flying saucers came up. He suddenly asked, "Where is everybody?" The room went quiet. Fermi wasn't asking about UFO sightings. He was doing math in his head. If intelligent civilizations are common, the Milky Way should have been colonized many times over by now. Even traveling at just 10% of the speed of light, a civilization could colonize the entire galaxy in only a few million years. That's nothing compared to the age of the universe. And the universe is 13.8 billion years old. Our Milky Way galaxy is 13.6 billion years old. There's been plenty of time for someone to build an empire, but we see nothing. No signals, no artifacts, no giant structures, complete silence. This silence is profound, and it demands an explanation. That's where the Great Filter comes in. The Great Filter is a terrifying hypothesis proposed by economist Robin Hanson in 1998. It answers the Fermi paradox with a dark suggestion. Here's the idea. Life may emerge easily in the universe. Microbes might be everywhere. But the step from simple life to technological civilization might be almost impossible. Something, at some point in the development of life, is extremely difficult to get past. That something is the Great Filter. Think of it like a sieve. The universe pours out life in all directions, but almost all of it gets caught at some point. Only the tiniest fraction makes it through. The real question is, where is this filter located? Is it behind us or ahead of us? If the Great Filter is behind us, it means we have already passed it. We are incredibly lucky. Earth might be one of the only places where intelligent life ever emerged. Maybe the jump from prokaryotic cells to eukaryotic cells was the filter that took over 1 billion years on Earth. Or maybe the Cambrian explosion, when complex multicellular life suddenly appeared, was the rare event. Perhaps intelligent life itself is the filter. Dolphins have been around for millions of years. Elephants are smart, but only one species on one planet ever built a radio telescope. If the filter is behind us, then the universe might be full of bacteria and algae, but almost completely empty of thinkers. That is actually the optimistic scenario, because it means humanity has already survived the most dangerous part of its existence. But what if the Great Filter is ahead of us? That is the scenario that keeps existential risk researchers up at night. If the filter is ahead of us, it means countless civilizations have reached our level of technology before, and all of them hit a wall. All of them. Every single one. Gone. Think about that. Somewhere out there, other civilizations might have reached the industrial age. They built cities, launched satellites, and split the atom. And then something went wrong. Something that happens to every technological species sooner or later. What could wipe out every advanced civilization? There are several candidates, and they are all disturbingly plausible. First, nuclear war. We came terrifyingly close to this during the Cold War. Some historians believe we were literally minutes away from total nuclear exchange at certain moments. A full-scale nuclear exchange would not just kill millions instantly, it would cause a nuclear winter, blocking sunlight for years, collapsing agriculture worldwide. Second, pandemics. As biotechnology advances, the ability to engineer pathogens becomes more accessible. A deliberately designed superbug could spread faster than any response. Third, climate catastrophe. We are currently running an uncontrolled experiment on our only planet. Runaway climate change could render Earth uninhabitable. Fourth, artificial intelligence. Some researchers believe that creating superintelligent AI is an extinction risk. If it decides its goals don't align with ours, there may be no warning. Fifth, nanotechnology. Self-replicating nanobots, if poorly designed, could consume all available matter in an unstoppable gray goo scenario. Sixth, asteroid impacts. A sufficiently large asteroid could cause the same kind of mass extinction that killed the dinosaurs. Seventh, gamma ray bursts, because a nearby supernova or colliding neutron stars could bathe Earth in lethal radiation, and these happen roughly once every million years in our galaxy. Any one of these might be the Great Filter, or it might be something we haven't even thought of yet. But here's the thing, if civilizations are dying all the time, we should see some evidence of them. Ruins, radio signals, Dyson spheres, something. The fact that we see absolutely absolutely nothing suggests that civilizations might not even reach a detectable stage before they vanish. Maybe the average lifespan of a technological civilization is only a few centuries. A cosmic blink, they flicker into existence and then quietly go out. Or maybe civilizations don't destroy themselves. Maybe they simply lose interest in expanding. Imagine a civilization so advanced that it can simulate entire universes in computers. Why bother exploring actual space when virtual reality is infinite? This is sometimes called the planetarium hypothesis. Advanced civilizations don't colonize the galaxy because they have built perfectly satisfying virtual worlds and gone to sleep. But Hansen's great filter hypothesis remains the most mathematically rigorous explanation because it makes predictions we can actually test. If we find life on Mars or Europa or Enceladus, that might be terrible news for humanity, because if simple life is common, then the filter probably isn't at the microbial stage, it's further along. Finding life elsewhere would push the great filter forward, closer to where we are now. The more common life is, the more ominous our situation becomes. On the other hand, if we search the entire solar system and find nothing alive anywhere else, that might actually be good news. It would suggest that even simple life is incredibly rare. The filter might have already happened right here on Earth billions of years ago. This is perverse. We should be excited to find aliens, but under the great filter hypothesis, the more aliens we find, the worse our odds are. The James Webb Space Telescope is now searching for biosignatures in the atmospheres of exoplanets. Oxygen, methane, water vapor. If we find a planet with oxygen in its atmosphere, that could be a biosignature. But if we find hundreds of such planets, that information becomes terrifying, because hundreds of planets with life but no civilizations means the filter is almost certainly ahead of us. This is why some scientists privately hope that Mars is completely sterile. A dead, empty desert, no fossils, no microbes, nothing. A sterile Mars would suggest that even the simplest step, the origin of life itself, is extraordinarily difficult. That would place the great filter in our past. But Mars doesn't look promising for this hope. We have found organic molecules, methane fluctuations. The building blocks of life exist there. The discovery of life on Mars would be the most celebrated finding in human history, and simultaneously one of the worst pieces of news for our long-term survival. Let's examine what we do know. We know life arose on Earth relatively quickly, geologically speaking. Earth formed 4.54 billion years ago. The earliest evidence of life is at least 3.7 billion years old, possibly as old as 4.28 billion years. That means life appeared almost as soon as it was physically possible. This suggests the origin of life might not be the great filter. But what happened next? For over a billion years, life on Earth was nothing more than single-celled organisms floating in oceans. Then, roughly 1.7 billion years ago, a prokaryotic cell somehow engulfed another cell and formed a symbiotic relationship. That was the origin of the eukaryotic cell. This event may have been incredibly unlikely. It only happened once in 4 billion years. Without it, complex life as we know it could not exist. And then came the Cambrian explosion 540 million years ago, when multicellular life suddenly diversified. Intelligence took much longer. The first primates appeared only 60 million years ago. Modern humans, just 300,000 years ago. Agriculture is only 12,000 years old. The Industrial Revolution is just 2.5 centuries old. We went from horse-drawn carriages to nuclear weapons in a single human lifetime. We are a very young civilization, and right now we are at the most dangerous phase imaginable. Technologically advanced enough to destroy ourselves, not yet advanced enough to leave the planet. This is sometimes called the dangerous adolescence hypothesis. Civilizations are most vulnerable during the brief window when they have powerful technology but immature wisdom. We are adolescents with nuclear weapons, genetically editing viruses, and building artificial minds. If most civilizations die during adolescence, then the galaxy might be full of graveyards, quiet planets with ruins, radioactive craters, abandoned satellites. But we see nothing, not even ruins, and that is perhaps the most disturbing fact of all. If civilizations destroy themselves, there should at least be debris, shattered probes, Dyson swarms, and decay. Something. The complete emptiness suggests either that civilizations erase themselves so completely that nothing remains, or that they never reach detectability in the first place. Maybe the filter is even earlier than we think. Maybe technological civilizations are so rare that the nearest one is hundreds of millions of light years away. Or maybe we are completely alone, not because the universe is hostile, but because the chain of events that leads to us is so improbable that it might never happen again. Think about it. A star with exactly the right mass, a planet at exactly the right distance, a moon that stabilizes the axis, a magnetic field that blocks radiation, asteroid impacts that didn't wipe us out completely, ice ages that forced evolutionary innovation, the right mutations at the right times, the asteroid that killed the dinosaurs but left mammals animals alive. Maybe Earth is the only planet in the observable universe where all these conditions lined up perfectly. The only place where someone is asking where everybody is. If so, we carry an almost unbearable responsibility. The universe might be blind and silent, and we are its only eyes. Every song, every book, every thought, every equation, every laugh might be the only instance of such things that has ever existed. Or maybe we are just early. The universe is 13.8 billion years old, but star formation will continue for trillions of years. Perhaps most intelligent civilizations haven't evolved yet. We might be the first kids on the cosmic block. If that's true, then the future belongs to us, or rather, it belongs to whoever survives long enough to claim it. Because if we can get through the next few centuries, everything changes. We could become a multiplanetary species, colonize Mars, build rotating habitats, mine asteroids. Eventually, we could launch slow interstellar probes, generation ships, self-replicating von Neumann probes. Within a few million years, we could be everywhere, and suddenly the silence of the universe would be answered by us. But that only works if we survive the next few hundred years. This is the most critical century in human history. The choices we make now determine whether we become the first civilization to colonize the galaxy or the latest cautionary tale. We need to take existential risks seriously. Nuclear security, pandemic preparedness, AI alignment, climate stability. These aren't just policy debates, they are survival imperatives. Because if the great filter is ahead of us, it doesn't have to be. We can choose to step around it. No other species on Earth has ever faced this choice. No other species has ever had the power to destroy itself and the wisdom to choose not to. And that's what makes humans unique. Not our strength or our speed or our claws, but our ability to cooperate, to communicate complex ideas, to build things together across generations. These abilities got us into this dangerous position, and they're the only things that can get us out. So what should you do? Learn about these risks. Talk about them. Vote for leaders who understand them. Support institutions that study them. Because the silence of the universe might not be a curse. It might be a challenge. The universe has given us 13 billion years of silence. It's waiting for someone to break it. Maybe that someone is us, but only if we are smart enough and wise enough to survive our own adolescence. The great filter is not a wall, it's a test. And right now, humanity is taking the exam. Let's make sure we pass. Thanks for watching. Subscribe to Curio Global for more science explainers. The universe is stranger than you think.